The 1946 Nobel Prize in Physics went to somebody you probably never heard of, a guy named Percy Bridgman. Spent his entire career up at Harvard, but we won't count that against him. No, I'm just kidding, folks at Harvard. We love you guys. You're great. Um, he won the prize for his invention of an apparatus to produce extremely high pressures and for the discoveries he made in the field of high pressure physics. Now, he was a bit of a recluse. So some of the people that win the prize are just very outgoing. They're very, they go to all the conferences, they talk to everybody, they're kind of friends with everybody. This guy was a bit of a recluse compared to some. And he actually had a lot of work that actually finds application even today, as we're going to see. But he's kind of well known for his extensive writing on the scientific method, as well as the aspects of sort of the philosophy of science, which really, in my opinion, should be included more in the undergraduate science education than it is. But yeah, that's a whole nother story and a whole nother video. But let's take a look at his work in high pressure physics, because I think it's really interesting and you're going to like it. On high pressures, matter takes on all kinds of new properties, and in some cases, bizarre new ones that you really want to study carefully. And Professor Bridgman set out to study some optical phenomenon under high pressure in 1905, and some of his gear broke. Well, why does that really matter? Well, this is a more modern pressure vessel, and when you see all these entry and exit points in and out of the vessel, you have to cover those with things, and you've got these nice seals, you've got nuts and bolts to hold it together. But if you pressurize that a little too much, or one of those things fails, or one of those nuts and bolts comes off, or whatever happens, you can send apparatus flying across the lab at something akin to the pressure that you're experiencing inside. Well, if that pressure is 8, 10, 12 times atmospheric pressure, some of those things can come off of there like a bullet. So you really want to be careful when you're dealing with high pressures, because you can cause lab accidents that could punch a hole in the lab wall, the building wall, go into the next building, and wind up going through 4 or 5 desks before they actually stop, and hopefully nobody gets stuck in the middle. So coming up with a way to do high pressures routinely and safely so that you can study them in constant high pressure environments without causing potential problems was a really big deal in 1905. What he came up with is a system called a pressure anvil. So what it involves is a hydraulic press on top and bottom, a sample chamber in the middle with a sample. You've got a fixed anvil on one side and a rotating anvil on the other, and those two are pressed together to cause enormous pressure in the middle. But you have to make sure of a bunch of different things. Are you using the right material that's going to be able to handle that much pressure without exploding? If you're going to a much higher pressure than most materials can handle, you may have to take your entire hydraulic press and submerge it in a liquid, and that will help you keep it from fracturing in different ways. There's all kinds of ways these things have to be used in order to ensure safety, but this method allows you to get to much higher pressures than any other method out there. Now, how high pressure can it get to? I don't know. Let's think about that for a second. How high is necessary? High pressure environments don't just appear magically, right? There's no way to go, oh, look, I've got to test something at high pressure, and let's just walk down to the local university and find it. That's not the way it works. It's a lot harder to do. But who cares, right? It's just a group of scientists trying to figure stuff out in the lab. It's not true. Well, it is, but there's also other times when this would matter. So there's been a lot of press lately about a submarine that was trying to visit the Titanic a bunch of times, and it ultimately failed, suffered an implosion. Everybody on board died. Testing submarines, you do that at high pressure so you can simulate it what it's like underwater without putting people at risk and be able to know exactly what your failure points are. High pressures are used in chemical manufacturing all the time, the food and beverage industry. Think about just how much pressure is under your favorite beer keg, or under some kind of a carbon dioxide tank for carbonated beverages. All of those things are high pressure vessels. They're not all anvils, but this sort of research helps us understand exactly what limits you can push those things to without them falling apart and causing a public hazard. Now, here's the big ones. Now, when I was younger, diamonds were things you dug out of the ground and sometimes wound up in jewelry, and they were very expensive. The prices of diamonds have been coming down lately, largely because synthetic diamonds have been finding their way onto the market. Those synthetic diamonds are created in a pressure anvil that's not that much different than the one he created to win the Nobel Prize. There's been advances and there's been, new things done to them. They're a little bit more advanced than they were, but the same basic premise applies. You're just taking something and squishing it together like that. And he built the first way to do that safely. He studied safely. He studied how to get that done without having it become a large hazard in the lab. And thanks to him, we now have diamond prices coming way, way down compared to what they used to be, along with a lot of other things that we wouldn't have had otherwise. So I hope you've enjoyed this video. We'll see you on the next one. Don't forget to click subscribe and like, and we'll see you soon.